So if the protons and the neutrons both have significant mass, then two isotopes that have different numbers of neutrons are going to have different masses, right? So the individual isotopes are going to have different masses. But when we deal with a sample of an element, we're dealing with a huge number of atoms. And they're in a particular proportion of one isotope to the other. It's just going to depend on which element we're looking at. So it's most useful to think about an average mass, because we almost never deal with individual atoms. So another number on the periodic table is the number directly below the element symbol. You'll notice that that number is not a whole number. That is the average atomic mass. So if you took all the atoms of that element, took their masses and averaged them together, that's what you'd get. There's not actually an atom that has that specific mass, because it's just an average. It's like you can have, if you have two children and one's 10 years old and one's 12 years old, the average age is 11, but neither child is 11 years old, right? Nobody's actually average. So instead of adding up a gazillion, almost literally a gazillion different masses and then dividing by a gazillion, we use a weighted average based on the percentage. So for chlorine, 75.77% is chlorine 35. Chlorine 35 atoms have masses of 34.97 atomic mass units. Notice that this number is very close to the mass number, but not exactly. 24.23% of chlorine is chlorine 37. So this chlorine has 2 more neutrons than chlorine 35. The atomic mass of that isotope is 36.97 atomic mass units, very close to 37. So to find the average atomic mass, we take this percentage and make it into a fraction, a decimal. We divide by 100, so 0.7577 times the mass of that isotope, and then we add the percentage made into a fraction, a decimal, 0.2423 times the mass of the other isotope. You do the math and you come up with 35.45 atomic mass units. That's the average mass of chlorine. There's 2 kinds. One is 34.97, one is 36.97. It's not just a straight average of those 2 numbers, because it's not 50% of each isotope. It's closer to 75-25. So this number, 35.45, is closer to the mass of chlorine 35 because more chlorine atoms are chlorine 35 than chlorine 37. Any questions? So in general, this is how we calculate it. From that percentage, you get the fraction of that isotope and you multiply it by the mass of that first isotope. And however many isotopes there are, you do that for each of them, you add them together. Any questions? Let's do an example. So magnesium has 3 naturally occurring isotopes. So here are the masses: 23.99, 24.99, and 25.98 atomic mass units. The natural abundances are 78.99%, 10%, and 11.1%. Calculate the atomic mass of magnesium. So we're going to take this percentage that goes with that isotope, we're going to make it into a fraction. We're going to divide by 100. So, what? Let's try that again. 0.7899 times the mass of that isotope, 23.99 atomic mass units, plus the next isotope accounts for 10% of magnesium. So we're going to take that and make it into a fraction by dividing by 100 times the mass of that isotope. And the third isotope accounts for 11.1%. So dividing that by 100, 0.1110 times the mass of that element, or isotope, 25.98 atomic mass units. So then we need our calculators. So 0.7899 times 23.99, the screen's too small, plus 0.1000 times 24.99 plus 0.1110 times 25.98 equals. So my calculator gives me this answer, 24.332481. The unit there would be atomic mass units. Let's try that again. Everybody get that number? Okay. As with any average, the average that you come up with should be between the highest and the lowest value. If you come up with an average that's larger than your largest value, you did something wrong in the calculation. So this being 24.3, it's less than the biggest one and more than the smallest one, so that gives me a fair amount of confidence. We should always think about significant figures. What's more important than getting the number of significant figures exactly correct is having the right idea and getting close, okay? So in this problem, we have multiplication and we have adding, and so that makes things kind of complicated, right? So what I'm going to do is I'm going to look at how the atomic masses were expressed. These all had 2 decimal points, and so that's going to suggest to me that I should round this to the 2nd decimal place. And then I also need to consider the percentages, because if they had given me like 79% with only 2 significant figures, then that's going to have an impact on my final answer. But these all had 4 significant figures, and so ending up with 4 sig figs here is entirely reasonable. You could also go through and do all the rules for sig figs and come up with the result. I don't think that's worth our time for these problems. The focus on this problem is, can you do the average? Can you calculate the average? And then let's try to be close with the sig figs. So I think it would be good to call this 24.33 atomic mass units. Any questions?